Hello viewers, welcome to Asha for Real online tutorial class. So our topic of today is first order ordinary differential equation. So today we are going to look at first order ordinary differential equation and the method of solution that we can use in solving them. Probably solve at least one example on first order ordinary differential equation. So the first thing we are going to do here is to show in general what is first order ordinary differential equation. We have y prime of x plus p of x y of x is equals to q of x. The equation on the board is the first order ordinary differential equation. They are all given in this form. Even if you have something of this nature, y prime plus 2y is equals to 4, this become first order ordinary differential equation. By comparison, you discover your y prime is here. You have y as coefficient of b here, you have y, but your q of x in this place is 4. So a system of this form of equation is first order ordinary differential equation. Now we are going to look at method of solution. And we have several methods of solution of first order ordinary differential equation. We call it method of solution. Method of solution. So one of the methods of solution we have is called separable method. Separable method. Then the second method we have is integrating factor method. We call it integrating factor method. Integrating factor method. Then we also have the Bernoulli method. This is one of the great mathematicians, the Bernoulli method. So, but as for the purpose of our today class, time factor will not permit us. So we restrict ourselves to the use of integrating factor method because that is where students usually find complicated or challenging. So we are going to look at how do we use integrating factor method to solve first order ordinary differential equation. So to do that, we are going to look at this example. Given that y prime minus 3 divided by x y is equal to x. The problem says we should find the solution to the differential equation. Y prime minus 3 divided by x, y is equals to x. So the first thing we do while solving using integrating factor method is to compare the general form of the differential equation, first order, and the given problem you have to solve. So let's do that comparison. We have, sorry for that. We have that we have y prime plus p y is equal q. This is in general. But the given problem, read y prime minus 3 divided by xy is equal x. So by the time we compare, if I call this equation 1 and I call this one equation 2, mathematics is that by comparison, by the time we compare, by comparison, so we can actually come up with this. Y prime we have in equation 1, look at it here. Your y here, look at it. Your q automatically become x. Your equality sign, you are saying it. So your p automatically become minus 3 upon x. So the first thing, we bring out the coefficient of the variable. We have p is equal minus 3 upon x by comparison, and our q is equal x. But our method of solution equation, every first order differential equation or every differential equation, the bone of contention is to find the value of y of x. And our general method of solution read y r is equals to integral of q r dx. This is the general solution of first order ordinary differential equation. Now, to do that, the only thing that is missing here in this equation is the r. However, we have our q, which is x. We can easily substitute x here. We have our p is not here, but we have r as a new variable introduced. Now, to get the value of r is equals to exponential integral of p dx. So that we will be able to get the value of r. That our r in this question is exponential integral of what is our p? Our p is minus 3 divided by x dx. Mathematically, this is the same thing as exponential minus 3 can be factored out. Integral of 1 over x dx. So we have this. And that gives us our r is equals to exponential minus 3. When you take integral of 1 over x, you have ln x. So you have integral in exponential minus 3 ln x. So this is still equals to, of course, you know that your ln function serves the same purpose as logarithm. That is natural logarithm to base e. So from the law of logarithm, you can write this as exponential ln x raised to the power of minus 3. And one of the properties of exponential is that exponential can eliminate ln function. So when we do that, exponential cancel ln, that is, you have exponential ln a mathematically is equals to a. Similarly, if you have ln exponential a, this is also equals to what? A. So they both have that property, they can cancel each other. So if you do that here, that will give our r to be equals to x raised to the power of minus 3. Now we've gotten all the parameters needed to solve the first order ordinary differential equation. So to do that, we have y. This is the general solution. Y r, our r is gotten already. We can substitute x raised to the power minus 3 is equals to integral. Q is known to be x. You put it x multiplied by my r is x raised to the power of minus 3, I'll put it. And what I have here is the x, I'll substitute my dx. So this will give me y x raised to the power minus 3 is equals to integral of, according to law of indices, two things multiplying each other having the same base. Choose one of the base, add the power. We have x raised to the power of 1 plus minus 3 dx. So this gives us y x raised to the power minus 3 is equal integral of x raised to the power plus times minus is minus. We have 1 minus 3 to give us minus 2. Minus 2 dx. So that we have y x raised to the power of minus 3 is equals to, mathematically, you have an expression like this. You want to integrate this function. That tells you are going to add 1 to the new power, to the original power it's having before. You have x raised to the power of minus 2 plus 1. And your new power divided by what? Minus 2 plus 1 plus constant of integration. In every integral, ensure to add your constant. Ensure to add your constant. So we have y x raised to the power of minus 3 is equal x raised to the power of minus 2 plus 1 will give you minus 1. Divided by minus 2 plus 1 will give us minus 1 plus constant of integral. But our the bone of contention in this problem is to solve for y. To get y now, we can simply multiply both sides. Multiply both sides by 1 divided by x raised to the power minus 2. So when we do that, we are going to have 1 divided by x raised to the power minus 3 multiplied by y x raised to the power minus 3 is equal, the whole of this, 1 divided by into, we have minus x raised to the power minus 1 plus c. So when we do that, this will take away this one. Our y, which is what we are looking for, is now equal to, we have minus, this is division, and of course one of the properties of indices says if you are dividing, choose one of the base, add the power. So we have minus x raised to the power of, we have minus 1 plus 3 plus this one we have c x is 0 plus, because there is no x here, we can say x raised to the power of 0. Of course, anything raised to the power 0 is 1. So we have 0 plus, when this is going up, plus 3. So finally, we can have our solution of y of x to be equals to minus x raised to the power of minus 1 plus 3 will give us 2 plus we have cx raised to the power of 3. So with this, the only thing that is common is x squared. We can take it outside. We have x squared into cx minus 1. That is the solution. So I hope you like the integrating factor method. If you have any question, you can actually um, ask on the comment section. And don't forget to click on the subscribe button. I wish you best of luck. Thank you.